Welcome to aminacademy.com. In electrical engineering, let us discuss about force of attraction between opposite charged plates. Look at here. Here, two parallel conducting plates A and B. The plate A and B. Force of attraction between them is F Newton. Here, this is a positively charged plate. Here, this negatively charged plate. Now, this is dx distance, it is pulled. Force of attraction, it is dx distance, it's pulled towards the positive charge. Now, the plates is pulled apart by the distance dx, that work done, force into distance dx. Now, initial stored energy due to this charge equal half of q square by c joules it is. The capacitance becomes C minus dc due to moment dx, due to moment of plate dx distance. Then final stored energy. Final stored energy is equal half q square over c minus dc, which is equal half q square, c we are taking out, and that, look at here, 1 over 1 minus dc over c, because we are taking c out. Then, which is further, look at here, this is equal half q squared by c, and it goes up as dc over c over minus 1. Then final stored energy, the final stored energy is this one here. Let it be this 2, equating 1 and 2 because both have force. Then f dx equal half q squared over c. Now here expanding binomial theorem by power minus 1 index, we can get it there. That is neglecting higher terms of dc over c, it becomes 1 plus dc over c minus half q squared c. Minus half q squared c. minus half q square, see initial here, minus half q square, or this is, let it be 2. Now look at here, then this opening the bracket, it becomes now, and which is finally equal f dx equal half q square c square dc. This final simplification. Now from this f equal dx go down, that is half q square over c square dc over dx, dc over dx. Now therefore this where, which is equal half v square dc over dx, since v equal to q over c. V equal to q over c, this is v equal to v square equal to q square over c square. So v equal to q over c. Then c is equal, we know that c equal epsilon a over x, distance x. Then therefore dc by dx equal minus epsilon a, because the plates come nearer, over x square, because against the force we are pushing, that plate is moving towards that positive charge. Then x square. Therefore from this we can get it, force F equal to minus half v square into epsilon a over x square. We are substituting this dc by dx here. Then here it's much newtons. Then further this we can say F equal minus half epsilon a into e square, also I can write it. This represents the force between the plates of parallel plate capacitor charged to a PD of volt V volts. The negative sign shows that the force of attraction. Now this is the expression for force. Now let us do an example problem. Look at here. A parallel plate capacitor is made up of square plate of 1.2 meters side length. Separation is 1.4 mm. The space between the plate is filled with dielectric of epsilon r equal 30, and 1 kilovolt potential difference is applied to the plates. Find the force of squeezing the plates together. That here now the formula F equal minus half into epsilon 0 epsilon r a e square. Because here epsilon is considered as epsilon r and epsilon 0. Then which is equal now E equal electric potential equal to V over D, which is equal. Now parallel plate capacitor is made up of 1 kilovolt. 1 kilovolt is 1000 volts over 1.4 square meter. D is 1.4, separation is 1.4 mm. So 1.4 into 10 power minus 3 meter, which gives 0.714 volt per meter. Now force of attraction equal half epsilon 0 epsilon r a e square equal half epsilon 0 is 8.854 into 10 raised to minus 12. Epsilon r is 30 for dielectric, 30 for dielectric, and 1 for epsilon 0 epsilon r. Next, into A plate area is 1.2 square, side square is 1.2, that's 1.2 square, the square meter, into then E equal E square equal 0.714 the square A square, that is we are getting half epsilon 0 epsilon r A E square, which gives, the simplification gives minus 2.731 approximate into 10 raised to minus 4 Newton. After simplification of this expression gives minus 2.731 Newton. This represents the force between the parallel plates capacitor. We have done. Please subscribe our YouTube channel.